Dear children, welcome to this channel. Nearly we have come to the end of the chapter Complex Numbers. Only 2 more videos to complete this portion. In the last video, I have explained De Moivre's theorem and some problems in it. In this video, we are going to see the extension, that is application of De Moivre's theorem. Let us start this class with the keynote of the previous video. In the previous video, I have explained De Moivre's theorem. What is this De Moivre's theorem? It states that when you want to take power n of a complex number where n is a positive integer, if the complex number is in the polar form, then it is obtained by multiplying that power to the argument. That is cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta for integer n. And sum of the results of this theorem is cos theta plus I sin theta the whole power minus n is equal to cos n theta minus I sin n theta. That is, this is true even for a negative integer. Then second result is cos theta minus I sin theta the whole power n is equal to cos n theta minus I sin n theta. That is, this result is true even for a negative imaginary part. Imaginary part is negative. And then cos theta minus I sin theta the whole power minus n is equal to cos n theta plus I sin n theta, where I is also negative and power is also negative. Then sin theta plus I cos theta the whole power n, where here sin ratio is in the real and the cos ratio in the imaginary part. Even if the complex number in this form, we can apply the De Moivre's theorem by taking I outside and transforming it to the proper form. That is, after taking I, this would become I into cos theta minus I sin theta. Then taking power n, we have I power n into cos n theta minus I sin n theta. And then one more result is modulus of z is equal to 1 represent a unit circle. So these are some results we learnt in the previous class. Mod z is equal to 1 means it represents a unit circle. That means circle with radius 1. Mod z is equal to 2 means it will represent a circle of radius 2. Mod z is equal to 3 means it represents a circle of radius 3, like that. Okay. Using De Moivre's theorem, we are going to see how to get the nth roots of a complex number. Now let us take a complex number to be z as r into cos theta plus I sin theta. So the general form is by adding 2k pi with the argument theta, you will get the general form of the complex number, that is r into cos of theta plus 2k pi plus I sin theta plus 2k pi, where k is an integer. This theta is a principal argument and this 2k pi is an integral multiple of this theta. So we have to take in the r as z in the general form. Now let us take n to be some positive integer and let omega be some other complex number, and that is omega be a nth root, one of the nth root of this complex number z. That is w is equal to z power 1 by n. Z power 1 by n means here z should have n roots. Among this, let omega be one of the root. So omega is equal to z power 1 by n. So this implies that omega power n will be equal to z. Now as omega is a complex number, let us take omega to be in the polar form as rho into cos pi plus I sin pi, where rho is its modulus and pi is its argument. As omega power n is equal to z, rho power n into cos pi plus I sin pi the whole power n is equal to z, that is r into cos of theta plus 2k pi plus I into sin of theta plus 2k pi. Now here apply the De Moivre's theorem as n is a integer. So cos n pi plus I sin n pi equal to r into cos of theta plus 2k pi plus I into sin of theta plus 2k pi. Now these two are complex numbers which are in the polar form and they are equal. Therefore their corresponding modulus and corresponding arguments are equal. So equating the moduli and arguments, we have rho power n is equal to r, which in turn implies rho is equal to r to the power 1 by n. And here the arguments, equating the argument, n pi is equal to theta plus 2k pi, or pi is equal to theta plus 2k pi divided by n, where k belongs to z. Therefore, after getting the modulus and argument value, we can replace it to get the value of omega, which is one of the nth root of z. So what is the value of omega? Omega is equal to rho is r power 1 by n and pi is theta plus 2k pi by n plus I sin theta plus 2k pi by n, where k belongs to z. So this is not a single value. Omega have a lot of values according to the value of k. When k is equal to 0 and k is equal to 1, 2, etc., it will have a lot of values. But for k is equal to 0 to n minus 1, omega will have distinct value. And for after that n minus 1, if you substitute k as n plus 2, etc., the same values will get repeated. And therefore, let us take the distinct values. For what for distinct values for which k takes the value 0 to n minus 1. So, what are the nth roots of z? R power 1 by n is equal to cos of theta plus 2k pi by n plus I sin theta plus 2k pi by n, where k takes the value 0 to n minus 1. So, from 0 to 1 minus n means how many values would be there? N values. So, z that is nth root of z will be n values, and it is given by r power 1 by n into cos of theta plus 2k pi by n plus I sin theta plus 2k pi by n. And then what are the nth roots here? If you substitute k as 0, it will become r power 1 by n into cos of theta by n plus 2 pi by theta by n plus I sin theta by n. And by substituting k is equal to 1, r power 1 by n into cos of theta plus 2 pi by n, that is theta by n plus 2 pi by n, and plus I sin theta by n plus 2 pi by n. And similarly, by substituting k is equal to 2, we have another third root is r power 1 by n into cos of theta by n plus 2 into 2 4 pi by n plus I sin theta by n plus 4 pi by n, etc. And by substituting k as n minus 1, we have r power n 1 by n into cos of theta by n plus 2 into n minus 1 into pi by n plus I into sin of theta by n plus 2 into n minus 1 into pi by n. So, these n roots, these n values are the nth roots of z. So, here we can observe some rules, observe some results here. Here we can observe some result, that is, look at the arguments. For the first root, theta by n, argument is theta by n, and for the second root, argument is theta by n plus 2 pi by n, and for the third root, theta by n plus 4 pi by n. So, this shows that the arguments of the nth roots differ by 2 pi by n. And then modulus of all the nth roots are same, and they are equal to r power 1 by n. And then also, if we plot all these roots, they will lie in a circle of radius r to the power 1 by n. So, this implies that z power 1 by n, that is omega, is equal to r power 1 by n as cos of theta plus 2k pi by n plus I sin theta plus 2k pi by n, shows that De Moivre's theorem is true for rational powers too, not only for integers. Even if you have rational 1 by n, then De Moivre's theorem can be applied. Here, look at this, power 1 by n, here we have divided the argument by n. So, this shows that De Moivre's theorem is true for the rational powers. Using the same concept of nth root of a complex number, let us find out what would be the nth roots of unity. That means nth root of 1. So, we are going to find out what is 1 to the power 1 by n. We are going to obtain n roots, and let us see what are the n roots of this 1. So, let us take this 1 to the power 1 by n to be z. So, this implies that z power n is equal to 1. So, z power n is equal to 1, that means 1 can be expressed as 1 plus I0. So, this is in the rectangular form, we have to express it in the polar form. In the previous video, I have said a shortcut method to write down it directly. Instead of finding r and alpha and then theta, directly you can write it by using the short form. You know that 1 plus I0 lies in the, again it is a first quadrant, that is exactly on the real axis, and moreover cos 0 is 1 and sin 0 is 0. So, instead of finding r, alpha, etc., directly you can write 1 as cos 0 and sin I into 0, this 0 as I into sin 0. See, directly you can change this into polar form. Now, adding the argument, adding 2k pi with the argument, it will become cos of 0 plus 2k pi plus I sin 0 plus 2k pi. Now, z is equal to cos 2k plus pi plus I sin 2k pi the whole to the power 1 by n. Now, as we have seen that De Moivre's theorem is applicable for rational powers, let us multiply it by 1 by n. So, we have cos 2k pi by n plus I sin 2k pi by n, where k is restricted to the value 0 to n minus 1. After applying the power, the value of k is restricted to 0 to n minus 1, because after that, even if you apply n plus 1, etc., the same values will be repeated. So, only n distinct values will be there. What are the n distinct values? The n distinct values are obtained by taking k as 0 to n minus 1. Therefore, let us write down the n roots of the unity. So, what are the nth roots of, that is simply we can write nth roots of unity. So, what are the nth roots of unity? One is by substituting k is equal to 0, we have cos 0 plus I sin 0, then k is equal to 1 means cos 2 pi n plus I sin 2 pi by n, and here by substituting k as 2, we have cos 4 pi by n plus I sin 4 pi by n, etc. So, we have n roots here, therefore, these n roots form the nth roots of this unity, nth roots of unity. Now, how to remember these values? Okay. So, we have to adopt a method to remember the values, the values of nth roots of unity. So, that is cos 0 plus I sin 0 is nothing but 1, because cos 0 is 1, sin 0 is 0, that is 1, and here cos 2 pi by n plus I sin 2 pi by n, cos 4 pi by n plus I sin 4 pi by n, etc. Now, in order to remember the values for nth roots of unity, let us adopt a method, follow a method. Now, let us take the second value, that is cos 2 pi by n plus I sin 2 pi by n be some omega. If we represent this as omega, now what happened to omega squared? Now, omega squared means cos 2 pi by n plus I sin 2 pi by n the whole square. That is applying the de Moivre's theorem, it would be cos 4 pi by n plus I sin 4 pi by n. Now, if you find out omega cube, it will be, you have to multiply the power 3, so it will be 3 2s are 6. So, cos 6 pi by n plus I sin 6 pi by n, and hence in this way, if you proceed in this way, what is omega power n minus 1? Cos of 2 into n minus 1 into pi by n plus I sin 2 into n minus 1 into pi by n. So, these are the other nth roots. So, if you take the second root as omega, then what would be the nth roots of unity? 1, this is omega, and this is omega squared, next will be omega cube, etc. to the last one will be omega power n minus 1. Okay. So, what is omega? Cos 2 pi by n plus I sin 2 pi by n, or you can write it in the represent even in the Euler form, e power I into 2 pi by n. Omega is nothing but e power I into 2 pi by n. Now, let us see what happened to omega power n. What is omega power n? Omega power n is equal to e power I into 2 pi by n the whole power n. Again, n and n will get cancelled on multiplying, e power I 2 pi, that is cos 2 pi plus I sin 2 pi. Sin 2 pi is 0 and cos 2 pi is 1. So, 1 plus I 0, that is equal to 1. So, omega power n is equal to 1, because nth root of omega represent one of the nth roots of unity. So, omega power n would be always equal to 1. Now, let us see the properties of nth roots of unity. So, you have have you understood this nth roots of unity? So, what are the nth roots of unity? 1 omega, omega squared, etc. to omega power n minus 1, where omega is e power I into 2 pi by n, and omega power n is equal to 1. Now, let us see some properties of nth roots of unity. Now, all the nth roots of unity 1 omega, omega squared, etc. omega power n minus 1 are in a GP with a common ratio omega. What is the first property? The nth roots of unity 1 omega, omega squared, etc. to omega power n minus 1 are in a GP with a common ratio omega. Let us see that. Now, GP means the ratios would be same. Therefore, let us divide find out T2 by T1. What is T2 by T1? Omega by 1 omega. Then T3 by T2 is omega squared by omega, again it is equal to omega, etc. T power n minus 1 by T power n minus 2 will be omega. So, all the ratios will be equal to omega, and therefore, 1 omega, omega squared, etc. to omega power n minus 1 form a GP with a common ratio omega. Then, let us, if you see the arguments differ by 2 pi by n. See, look at the nth roots of unity. What are the nth roots of unity? 1 cos 2 pi by n plus I sin 2 pi by n, which is omega, and this is omega square, that is 4 pi by n, and the next one will be 6 pi by n, etc. Look at the difference, 2 pi by n and 2 pi by n plus 2 pi by n is 4 pi by n. 4 pi by n plus 2 pi by n will be 6 pi by n. So, the arguments differ by 2 pi by n. So, that is the second property. Then, sum of all the nth roots of unity is 0. That is, if you add all the nth roots, that is 1 plus omega square plus omega power n minus 1, the sum will be equal to 0. This is another property, that is third property of nth roots of unity. Let us see how we got the sum as 0. As 1 omega square, etc. is a GP with a common ratio omega, then 1 plus omega square plus etc. omega power n minus 1 is sum of n terms, and you know the formula for sum of n terms of a GP is a into 1 minus r power n by 1 minus r. So, a, the first term being 1, and r, the common ratio is omega. So, the summation of this one is equal to 1 into 1 minus omega power n by 1 minus omega. Then 1 minus omega power n by 1 minus omega, you know that omega power n is equal to 1. So, 1 minus 1 by 1 minus omega, that is numerator 0, therefore, the entire value becomes 0. So, what is the sum of all the nth roots of unity? The sum of nth roots, all the nth roots of unity will always be equal to 0. Next, fourth property says about the product. So, what is the product of all nth roots of unity? That is differs according to the power. So, that value is the product of all the nth roots of unity is minus 1 the whole power n minus 1. Now, let us see how we get this value minus 1 the whole power n minus 1 as its product. Now, 1 into omega squared etc. to omega power n minus 1 is equal to the product of everything with 1 will be the same thing. So, omega into omega squared etc. to omega power n minus 1. So, here the powers are to be added as the bases are same. So, adding the power 1 plus 2 plus etc. to n minus 1. So, that is sum of first n minus 1 natural number. So, its value is summation is n minus 1 into n minus 1 plus 1, that is n divided by 2. Now, what is omega? Substitute its value cos 2 pi by n plus I sin 2 pi by n the whole power n into n minus 1 by 2. So, as it is a rational, we can apply the de Moivre's theorem because it is true for rational power too. So, let us multiply n into n minus 1 by 2 to the argument. So, it will become cos of 2 pi by n into n by 2 into n minus 1 plus I into sin of 2 pi by n into n minus 1 by 2. Now, this n being cancelled, we have and 2 and 2 get cancelled, pi into n minus 1 plus I sin pi into n minus 1. Now, again apply the de Moivre's theorem and move this n minus 1 to the power. So, what you have cos pi plus I sin pi to the power n minus 1. Now, sin pi is 0 and cos pi is minus 1. So, minus 1 plus I into 0, that is minus 1 the whole power n minus 1. So, the product of what is the product of all the nth roots of unity? It is equal to minus 1 the whole to the power n minus 1. So, according to n even or odd, the value will get changed to minus 1 or plus 1. It will fluctuate from minus 1 to plus 1, but the sum is always 0 and the product will be either minus 1 or plus 1 according to the value of n. And then what would be the geometrical representation of the nth roots? All the nth roots will lie on a unit circle, that is circle with radius 1. And then if we join all the nth root, the points, they form the vertices of a regular polygon with the n sides. Regular polygon means polygon of the sides with equal sides. Okay, that is the meaning for regular polygon. So, what is the geometrical interpretation of the nth roots? All the nth roots lie on a unit circle and then with radius 1, and then if we join the points, then you will get a regular polygon with the n sides. See, this is a geometrical interpretation. So, I have drawn a circle with radius 1 unit where real axis and this is the imaginary axis. This point is 1 and this will be I minus 1 and minus I. So, if omega is there with an angle 2 pi by n and omega squared will be here with an argument 4 pi by n, that is the angle from real axis to omega squared will be 4 pi by n. Likewise, all the other nth roots of unity are placed in the unit circle and omega power n minus 1 will be here, lie here. So, all the nth roots of unity lie on a unit circle. Now, the sixth property is omega power n minus k is equal to omega power minus k is equal to omega bar the whole power k. All are equal for where k is nothing but a value between 0 to n minus 1. Now, let us see how you obtain this result. Okay. Now, modulus of omega is equal to 1, you know that, and therefore, modulus of omega squared is also equal to 1, and then modulus of omega squared means omega into omega bar is equal to 1 or omega bar, that is the conjugate, is equal to 1 by omega. 1 by omega is nothing but its inverse, we can represent it by omega power minus 1, that is omega inverse. Therefore, omega bar the whole power k is equal to, when you take the power k, it will be equal to omega power minus 1 the whole power k, that is omega power minus k, and also omega power n minus k can be expressed as omega power n into omega power minus k, but omega power n being 1, it will be equal to omega power minus k. So, omega power minus k is also equal to omega bar the whole power k or omega power n minus k. Therefore, all the three are equal. And what is k? K is nothing but a value between 0 to n minus 1. Now next example 2.32, find the cube roots of unity. Just like nth roots of unity, we are going to find out what are the cube roots of unity, and often we use this cube roots of unity. Therefore, let us find out what would be the cube root of unity. What are the cube roots of unity? Now let z is equal to 1 to the power 1 by 3. Cube root means 1 by 3. For unity means 1. So for what are the roots of 1 to the power 1 by 3? Now z is equal to 1 to the power 1 by 3 implies z cube is equal to 1. Z cube is equal to 1 means here 1 can be expressed as 1 plus I0. Again 1 is nothing but cos 0 and 0 is sin 0. So directly we can represent in the polar form, and adding the 2k pi with we have converted it to the general form, that is cos of 0 plus 2k pi plus I sin 0 plus 2k pi, where k takes a value, that is k0, 1, 2, 3 etc. And then z is equal to cos 2k pi plus I sin 2k pi the whole to the power 1 by 3. Then applying the De Moivre's theorem, we have cos 2k pi by 3 plus I sin 2k pi by 3, where k is restricted to only 3 values 0, 1, 2. Here it is 3 means only 3 values, n means n minus 1, 3 means 3 minus 1, that is 2, only 3 values 0, 1, 2. Now substituting 0, k as 0, 1 and 2, we get 3 values for z, that will be the cube roots of unity. Now on substituting k as 0, what do you have? Cos 0 plus I sin 0. Then substituting k as 1, we get cos 2 pi by 3 plus I sin 2 pi by 3. And then next one, the last one is 2. By substituting 2, we have cos 4 pi by 3 plus I sin 4 pi by 3. So we have obtained 3 values, and these 3 values are the cube roots of unity. Again, let us represent them by omega. For our to remember it easily, let us represent them by omega. As in the previous case, that is nth roots of unity, let us take the second one, because cos 0 plus I sin 0 is 1. So let us take the second value to be some omega. Now here before representing it, let us simplify it, because pi by 3 is a specific value. So let us simplify and let us find it exact value here. So what is 2 pi by 3? Cos of pi minus pi by 3 plus I sin pi minus pi by 3 here, and 4 pi by 3 is pi plus pi by 3. It can be split as pi plus pi by 3 and I sin pi plus pi by 3. So pi minus pi by 3 means this angle lies in which quadrant? Second quadrant. Second quadrant, cos negative, sin positive, and therefore it is minus cos pi by 3 plus I sin pi by 3. Pi plus pi by 3 means this angle lies in the third quadrant. In third quadrant, both cos and sin will be negative. So minus cos pi by 3 and minus I sin pi by 3. Now replace the corresponding values. Cos pi by 3 is 1 by 2, sin pi by 3 is root 3 by 2. And here again substituting the values of cos pi by 3 and sin pi by 3, we have the cube roots of unity as 1 and minus 1 by 2 plus I root 3 by 2. Another one is minus 1 by 2 minus I root 3 by 2. So these are the cube roots of unity in the polar form, and we have transformed into the rectangular form. Even if we are transformed into rectangular form, instead of remembering it easily, let us represent the second value as usual by omega. So in order to remember the cube roots of unity in an easy way, let us represent the second value by omega as first being 1. So let us take this to be some omega. So what would be that is if we take minus 1 by 2 plus I root 3 by 2 be as omega, and if you find out the square omega square, then omega square would be equal to minus 1 by 2 minus I root 3 by 2. Therefore, what are the cube roots of unity? 1, omega and omega square. And what is the value of omega? Minus 1 by 2 plus I root 3 by 2 in the rectangular form, or it is equal to cos 2 pi by 3 plus I sin 2 pi by 3 if it is in the polar form. Therefore, and then what happened to omega cube? Omega cube will be the repeated value. After 3 values, when if we substitute again, it will be equal to 1 omega square. The same one will get repeated. So omega cube is also equal to 1. Even if you take cube of that, you will get omega cube will be equal to 1. Then, what is the geometrical representation of a cube roots of unity means? They will all the 3 points lie in the circle of radius 1, that is they will lie in the unit circle. Then if we plot the point, what is the first one cube root of unity? That is 1. So 1 lie on the real axis. So this point is 1, and then omega, what is value of omega? Minus 1 by 2 plus I root 3 by 2. That means it lies in which quadrant? Second quadrant. So let us take this omega here, and then the third one would be both is negative. So x and y are negative means that point lies in the third quadrant. So omega squared will be here, and then because they are conjugate to each other, so exactly lies directly opposite to that. So if we join these three, you will have a equilateral triangle. Okay. So, by joining the nth roots of unity, we will have a regular polygon of n sides. Here cube roots of unity. So, if we join them, we will get a polygon of 3 sides. A polygon of 3 sides is nothing but a triangle, and regular polygon means all the 3 sides should be equal. So, it will form a equilateral triangle. And also we can see that all the properties satisfies this. All the properties of nth roots of unity is also satisfied here. That is, for cube root of unity, all the properties are satisfied. Omega power n is equal to 1 there. Here omega cube is equal to 1. And if you add 1 plus omega squared, what happen? 1 plus omega squared means everything will get cancelled, because minus half and minus half become minus 1, and 1 and minus 1 get cancelled, and these two get cancelled. So, sum of them will be equal to, sum of the cube roots of unity will be equal to 0. And what happens to the product? 1 into omega squared is nothing but omega cube is equal to 1, and this 1 can be expressed as minus 1 the whole square, which is also true. So, the product is equal to minus 1 the whole power, that is n minus 1, 3 minus 1 is 2 here. So, minus 1 the whole square, that is equal to 1. So, that property is also true. And look at the argument differs by, for nth root 2 pi by n, here cube root means the arguments should differ by 2 pi by 3. Look at the argument. First one is 0, for the first root it is 0, second argument is 2 pi by 3, 0 plus 2 pi by 3, third one is 2 pi by 3 plus 2 pi by 3, that is equal to 4 pi by 3. So, the arguments differ by 2 pi by 3. And then moreover, what is the omega power 4? Omega power 4 is nothing but omega cube into omega cube is 1, that is equal to omega, and omega power 5 is equal to omega cube into omega squared, again omega cube is 1, which is equal to omega squared. And what is omega power 6? It is omega cube the whole square, that is 1 square 1. So, the same value will get repeated again and again. So, whatever the power of omega, even if it is more than 3 or more than 2, we can replace it again as 1 omega or omega square. Now, next example is 2.33, that is find the fourth roots of unity. Like cube roots of unity, we can find out fourth roots of unity. That is, what would be the fourth roots of 1 to the power 1 by 4. So, that roots are called fourth roots of unity. Let us take this as z. So, z power 4 is equal to 1. As usual, it can be expressed as 1 plus I0. 1 can be replaced as cos 0 and this 0 as sin 0. And by adding 2k pi, we have cos 2k pi plus I sin 2k pi. Then what would be z? By taking the fourth root, cos 2k pi plus I sin 2k pi the whole power 1 by 4, again dividing it by 4, that is applying the de Moivre's theorem, 1 by 4 is to be multiplied. So, it will become cos 2k pi by 4 plus I sin 2k pi by 4, where k is restricted to 4 values 0, 1, 2 and 3. So, power is 4 means only 4 values starting from 0, 0, 1, 2, 3. Now, substituting k as 0, the first root is cos 0 plus I sin 0. Then by substituting 1, we have 2 pi by 4 plus I sin 2 pi by 4, and substituting it as 2, we have 4 pi by 4, and then substituting k as 3, we have cos 6 pi by 4 plus I sin 6 pi by 4. Now, cos 0 plus I sin 0, this can be simplified as cos pi by 2 plus I sin pi by 2, and here 4 and 4 get cancelled, cos pi plus I sin pi, and here cos 3 pi by 2 plus I sin 3 pi by 2. Now, we can write its value as they are known angles. So, cos 0 plus I sin 0 is nothing but 1, because sin 0 0, cos 0 is 1, and here sin 90 is 1, cos 90 is 0. So, 1 into I, and here sin pi is 0, cos pi is minus 1. So, we have minus 1, and 3 pi by 2 means sin 3 pi by 2 is minus 1 and cos 3 pi by 2 is 0, therefore, minus I. So, what are the fourth roots of unity? Fourth roots of unity are 1, I, minus 1 and minus I. Even you can represent this by omega by taking the second one I as omega. Therefore, if omega is taken as I, then we have the fourth roots of unity are 1 omega, and this will be omega square, and this is omega cube, where omega power 4 is nothing but 1. And if what is the geometrical representation of fourth roots of unity? If we plot all the 4 points, and then they are exactly lie on the real axis, positive real axis, negative real axis, positive imaginary axis and negative imaginary axis. So, if we plot down the points and if we join them, you will get a square, because all the 4 sides will be equal. So, they will form a square. So, the fourth roots of unity will be the vertices of a square. And also if we, what is the sum of the root, you know that sum of the fourth roots of unity must be equal to 0. By adding them you will get 0. And then what is the product? The product will be equal to minus 1, because minus 1 the whole power n minus 1, the product will be always be equal to minus 1 the whole power n minus 1. Here n is 4, 4 minus 1 is 3, minus 1 the whole cube equal to minus 1. So let us multiply here all the 4 roots, 1 into I into minus 1 into minus I, that is equal to I square. I square is nothing but minus 1. So that is also true. And look at the arguments, they differ by 2 pi by 4. So in this way we can find out cube roots of unity and fourth roots of unity. Even we can find out 6th root, 8th root, 9th roots of unity, like that. By take the first one would be 1 and then represent the second one by omega, and the next one would be omega squared, omega cube, etc. For example, if you want to find out 6 roots of unity, means the first one, what would be the 6 roots of unity? One is 1 omega, omega squared, omega power 5, etc. to omega power 5, where omega power 6 is equal to 1. This is the way to find out some nth roots of unity. Now let us see the example 2.35. Find all the cube roots of root 3 plus I, not for 1 but a complex number root 3 plus I. So you are asked to find out what is root 3 plus I the whole power 1 by 3. So let us take this z as z. So z cube is equal to root 3 plus I. So we have to convert this root 3 plus I to polar form, either by taking it as r cos theta plus I sin theta, or using the shortcut method which I have explained in the previous video. So here I have taken it in the form r into cos theta plus I sin theta, where r is equal to square root of x square plus I square, that is 3 plus 1 root 4, which is equal to 2, and this one lies in the first quadrant. Theta and alpha are equal, that is equal to tan inverse of y by x 1 by root 3 pi by 6, or directly you can divide it by 2 and multiplying it by 2 we can replace it as cos pi by 6 plus I sin pi by 6 using shortcut method. So what is z cube? Z cube is equal to 2 into cos pi by 6 plus I sin pi by 6. So this is the principal argument. So to get the general one, so add 2k pi, where k takes a value 0, 1, 2, etc., etc. Now taking LCM, 6 into 2, that is 12k pi and pi here. So the taking pi outside, we have 12k plus 1 into pi by 6 plus I sin 12k plus 1 into pi by 6. Now this is z cube. So what is z? You have to take a cube root on both sides. By taking cube root, we have z is equal to 2 power 1 by 3 into cos of 12k plus 1 into pi by 6 plus I sin 12k plus 1 into pi by 6 to the power 1 by 3. Now 1 by 3 is to be multiplied by de Moivre's theorem. So it will become pi by 18. So where k, the value of k is, after applying the de Moivre's theorem, the value of k is restricted to 0, 1, 2, because again if you substitute 3, 4, etc., the values get repeated. So we can take the value as k is restricted to for 0, 1 and 2. So what would be the cube roots of z? First, when k is equal to 0, z is equal to 2 power 1 by 3 into cos of, this k 0 means only pi by 18 plus I sin pi by 18. And then when k is equal to 1, z is equal to 2 power 1 by 3 into cos of, when k is, substitute k as 1, 12 plus 1, 13 pi by 18 plus I sin 13 pi by 18, and when k is equal to 2, z is equal to 2 power 1 by 3 into 25 pi by 18. See, instead of even writing cos pi by 18, even you can write like this, 2 power 1 by 3 into cis pi by 18. Okay, in short form we can write like this, or 2 power 1 by 3 into cis 13 pi by 18. And here 2 power 1 by 3 into cis 25 pi by 18. Okay. So cos, c, I and s together written as cis, like, okay, in short we can write like this. Now 25 pi by 18, we can also split this as pi plus 7 pi by 18, that is 18 ones are 18, 18 plus 1 7, so 7 pi by 18, that is pi minus pi plus 7 pi by 18, where cos is negative, so it will be minus cos. Sorry, pi plus means it lays in the third quadrant, both cos and sin are negative, so it will minus cos and minus sin. Okay, so these are the three values. Even you can stop with this cis to 25 pi by 18, or you can reduce it to minus cos 7 pi by 18. See, we know that arguments differ by 2 pi by n. What is n? N is 3. So here the arguments should differ by 2 pi by 3. But it cannot be seen directly. But we have to check, we can check whether it is whether the arguments differ by 2 pi by 3. What is the first argument? It is pi by 18. So the first one is pi by 18. The second one is, for the second root, the argument is 13 pi by 18. So 13 pi by 18 means, that is, if you add pi by 18 the first argument with 2 pi by 3, the summation will be equal to 13 pi by 18. So taking LCM 18, and here you have to multiply with then 6 and 6 again you have to, by taking this, you have to multiply this with 6, 6 2 is 12, 12 plus 1 13. And similarly the argument of the third root is 25 pi by 18, and this is also obtained by adding pi by 18 by 2 pi by 3 with 13 pi by 18, or 4 pi by 3 with pi by 18. So their arguments differ by 2 pi by 3. So even though it is not visible directly, if you find out, if you add 2 pi by 3 with the first argument, you will get the second one. Again, if you add 2 pi by 3 with the second one, you will get the third one. So the result, arguments differ by 2 pi by 3 is equal, is true. Now one more result, and for a complex number z, if you multiply e power I theta with z, and this represent a complex, another complex number, by rotating this z through an angle theta in the anti-clockwise direction. So as in the case of rectangular coordinates, if you multiply I with z, it will take a position which is multiplied by an angle 90 degree rotated in the anti-clockwise direction. Likewise, if a complex number is in the polar form, and if you multiply again cos theta plus I sin theta, then it will move to a position in the circle with radius r, and then with the argument is added by that theta. That is, if z is equal to r cos pi plus I sin pi, then what is z into e power I theta? The position, it will be the argument theta is added with this argument pi. So if this is z with the radius r, that is modulus r, then z lies in the circle with radius r, then what would be the position of z into e power I theta? It will move to a place where the argument is theta plus pi, that is theta is added with pi. So it will move to an angle, total angle theta plus pi from the real axis. This is called rotation rule.